Welcome to the Mechanical Assembly Lab here at PC1. Tonight I'm going to give you a quick update on the progress of the build and the assembly of the very first GT50 prototype. Let's start with the rotor. Now, in the last AMA we showed you the first GT50 rotor that we'd built, which was really about proving that each of the individual components that make up the high-speed rotor were made accurately enough for the balancing provisions that we had made to be viable for getting the thing balanced to the tolerances that we need to, so it runs smoothly and without vibration in the engine. We did all that successfully, so now we've gone ahead and built the final versions of the rotor, which are the ones that will actually run in the engine. So this is the actual test impeller, this is the first intermediate stub shaft that we're going to use, this is the disc that we'll run with, and then you'll remember when we showcased this originally, the original blades weren't properly secured in the disc with the original design of spring clips. We've now resolved all of that, and as you can see, all of the blades are robustly fitted into the disc so that they'll stay in position even when there's no centrifugal load on them. So this is now ready to be balanced, and then once this has been balanced we can disassemble it again, and then it can be built in situ within the engine. And then these of course are also our in-house cast turbine blades that also are now ready to go. To support a seamless test process, as I've explained previously, we've also built a lot of spares for the engine as we've gone through the process. So we've got a batch here of at least another engine set's worth of turbine blades. These ones have just come back from X-ray, and we'll be going through the sort of results of these and sorting these into ones that are viable for testing and ones that we can use for other mechanical purposes. We've got a spare compressor, we've got a spare turbine disc, and then this is the latest blade liner. So the blade liner sits around the turbine blades inside the engine and creates those close gaps that we need to make it work properly. This has now been fully machined so that we've got the exact profile and the exact tolerances we need to hold those really tight tip clearances to give the engine the performance it needs. On top of that, we've also completed a lot of the really fiddly bits that you need for the engine as well. So this is a seal carrier ring. This sits into the back of the blade liner and provides the precision surfaces that we need to fit the metal-to-metal seals that we use to keep all of the relevant chambers in the engine pressurized to the levels that they need to so that the engine functions correctly. So that's the blade liner and the seal vane. We've previously shown you all of the Curvic seal clips that we've made. Those are all sat here ready. We've got replacement intermediate shaft, replacement stub shaft, replacement tie bar, locking nut. The nozzle guide vanes that we've shown are have now completed their machining operations, so they're all ready to be installed as well. We've also got, again, the seal carriers that go onto the back of the nozzle guide vane and provide the flat surfaces that we need to be able to seal against to get all of the cavities that we require in the engine sealed properly so that the engine functions properly. So with the rotor in good shape, that's off to balancing next, and then we can get it into the engine. But to support the rotor in the engine, we're then into our spring bar system, our squeeze film dampers, and our in-house manufactured bearings. So if we start at the top here, this is the rear bearing. As you can see, the spring bar here, the polished raceways, there's the internal race that carries the ball and the rollers. That's all here. We've got the cages. We've got a few of those over there that have now been silver plated and ready to go as well. Then you've got the inner race and also the cage system there. And then here we've got the front bearing arrangement here waiting to go into the engine. So you've got the front spring bar, so the squeeze film damper is formed around there. We've got some piston rings that go in here. You've got the outer race there for the balls that carry the thrust loads. This is the outer part of the squeeze film damper, so we pump oil in through these tiny holes here, and that gets trapped in between the seals there to create the dampers that smooths out all the rotor dynamics of the engine. So all those components are here and waiting to go. And this is one of the Hill manufactured split inner race bearings. So that's the inner race of the ball bearing that sits inside that arrangement over there. And then the relevant locking apparatus. Here's the high temperature resistant ball bearings that go into the bearings, and all of that stuff is sat here. We've got spares for all of these as well, so if we get the lubrication wrong in the early tests, we can also replace those relatively quickly. Once we've got the rotor installed and the bearings installed in the engine, the next thing we need to do, of course, is make fire. So here is the actual test combustor. We've featured this quite extensively over the last few weeks. You have seen that before. That's now ready to go into the engine, with the exception of a couple of final holes that will pop in just before we assemble it, once we've completed the final round of combustor testing on the combustor rig that I'll show you later. This is the front end of the combustor. It's now a sliding assembly to cope with the thermal expansion. That's all ready to go, and then when that's together, it looks like that in the engine, but it's now got a sliding joint along here, as I've just shown you. So into the back of the combustor, we've got our fuel nozzles. So these have all been test assembled and leak checked. So we've got the swirler assemblies that I showed you previously. Within the swirler assemblies just create the swirling flow we need to help atomize the fuel. You've then got the fuel nozzle, the fuel manifold, all of the sealing provisions. All of those are here now and ready to go. And as part of the sort of setup for the engine, we've also got the range of fuel nozzles ready to go as well, so that we can fully characterize and optimize the combustion settings within the engine. So all that sat here. The nozzles have been pre-assembled and checked and leak checked. That's all ready to be assembled into the main engine over the next few days or so. So we've also got the igniter, the spark plugs, and also the high tension cables. Those are all here waiting to go onto the casing as well. So that's all good. We've got the bearing housing and the seal carrier. And then here, at long last, we've got essentially all of the structural components for the very first GT50. So we've got the inlet casing here. This is the bell mouth that draws the air in. Inside here, we've got the intermediate casing. This is the shroud that sits inside that lot. So as you can see here, we've now machined the abradable coating. We've got some little witness rub marks on here, so that we've got a simple way of measuring exactly what the tip clearance is when we run the engine for the first time. So that's all here and ready to go. This is actually the non-instrumented version of the combustor casing, as the one thing that we're waiting for to do this assembly operation now is the last couple of ops on this combustor casing. That's still downstairs on the 5-axis. It needs a few more hours to finish off. So we've been using the non-instrumented one to do all of the trial fits of this hardware. So what we've been doing this afternoon is just fitting these components together for the very first time, making sure everything goes together, make sure all the holes are in the right place, and just doing the very, very early trial assemblies. The thing you have to understand about this whole process is, given the fact we've spent nearly 6 months now painstakingly building all of these components, you can't just throw this engine together. So in the first instance, we build sub-assemblies, test they go together, test everything fits properly. In the case of things like the sealing rings and the components that have to carry the metal-to-metal seals, all of those things have to be trial fitted. We have to make sure the seals get the right compression and it's all uniform. And once all of those things are correct, we can then strip the engine again and start building it with the instrumentation, because the instrumentation, as I'll show you shortly, has lots of cables, lots of hypodermic tubing runs that sort of tie the engine together once you've built it. So we want to put that in once on the final build. So it's a very step-by-step process. The thing will be taken apart and put together loads of times before we're actually ready to run it. But that's just about doing the job properly and making sure that we don't damage any of these components or jeopardize the test by not putting it together as per the design intent. So the work that we're doing at the moment is very methodical, very careful, and making sure that when this thing does go together, it works properly. So down at the front here, we've got this is actually the casing that sits on the very front of the engine. So it picks up the starter generator and a bunch of the other accessories, and then supports all the bearings inside the engine for the accessory gears. So I think I mentioned in the previous AMA that one of the longest lead time items that we'd got was the accessory gears. So it's actually this fellow here. which is the accessory gear that sits on the front of the gas generator shaft and spins at nearly 50,000 RPM. Really, really tight tolerance component. So we've got one there and a spare in case we damage it. And then we've got a number of gears like this as well, which are the bigger accessory gears. This one's got the timing slots for the N1 sensor, and that's the one that actually drives the starter generator for the prototype engine. We've shown you these previously, but we've got all of the service pipes that are now ready to get the air and oil into the core of the engine. We've got a lot of the components that you probably won't think about, like floating washers to attach the combustors as the engine expands and contracts, and then a lot of the hardware that we need to attach things around the outside of the engine and seal that into a gas-type pressure vessel. So all those things are here and ready for assembly. Now, you'll remember probably 3 months ago, we were talking about the thermomechanical work that we were doing to compute how the engine expands and contracts under all operating conditions. Now, the reason we had to do that, and the reason we had to do that so precisely, is because in order to seal the different cavities at different pressures within a turbine engine, you have to use a variety of metal seals. So we've got two primary types of seals. We've got piston ring type seals here, where we seal on an outer radius or a radial gap. We've got all of these seals here now that seal around the big diameters in the engine. And then we've also got these omega and W seals, which are a bit like a concertina profile. And these get squashed up between two faces. So these rely on the quality and the accuracy of those machine faces to seal at all. And so if you look at the range of seals that we've got here, all of this hardware that you can see up the corner here, all of this stuff are the variety of different seals that we need at different locations in the engine to be able to seal it and make sure it functions properly. So all of those are here, and we're now painstakingly trial fitting each of these to make sure every seal in every location has got the right face and it seals properly and the contact pressure is right and everything goes together just right so that that engine functions properly when we test it. And the reason for that is, as you can imagine, looking at that thing from the outside in, you can't get at anything, you can't see at anything. We'll just get a witness of one of these things not working in the instrumentation. It's really a significant teardown to get it off the rig and back to pieces to fix it. So it's really important that we step through these stages now carefully to give us the best possible chance of having the least number of problems when we start to run the engine. And then as we move backwards here, you've heard me talk a lot about the instrumentation that we've got around the engine, pressure sensors, thermocouples, all sorts of strain gauges and various other things. All of this instrumentation is here. So we've got a variety of thermocouples, we've got all sorts of connectors, electrical connectors, pneumatic connectors, meters and meters and meters of different diameter hypodermic tube to be able to get the pressure signals out of the engine. All of those things are here now, pressure sensors, for example. And then when you've heard me talking about the rakes and things, where you can see in the engine here to be able to measure your measured gas temperature, which is what we'll use to control the engine, we've got this pink rake here. And that's the actual physical part here waiting to go into the engine. And then all the connector blocks that we use to go back to our instrumentation, all that sort of stuff's here as well now. You'll recognize the exciter box and the igniter plugs. And all this good stuff that goes together. Now, on top of all of those things, then we've also been developing the test rig and the control system for the engine. So this is going together at the moment. This is the control panel that we'll use to run all of the offline systems, the lubrication system, the fuel system, and a lot of the other things that we use to ventilate and control the container and the test house. So all of this stuff is in build at the moment. We've got the boards, we've got the inverters and the various electrical controls for the various pumps that we use in. All of this sort of stuff is coming together now at pace. So the hard yards of building all of these components for the very first time is behind us now, and we're working through the careful task of building this very first one for the very first time. And then we can finally get it on the rig and start making jet engine noises.